router. So router is an intelligent device. Router switch both are intelligent device. Only the half is dumb device. So what is the function of the router, right? So if this is a router, at the layer 2, what do we call frame? At the layer 2, we call it as a frame. Layer 3 packet. So layer 3 packet means this is router. As soon as router receives a packet on its interface, it will open a layer 3 header. Layer 3 header is what? IP address, source IP and destination IP. So in the packet, like we have the entire data, IP address, in that source IP and destination IP, MAC address, source MAC, destination MAC, CRC and FCS. So when a packet comes to router interface, router will open a layer 3 information and it will refer the routing table. Layer 3 routing, right? So it will refer the routing table and take the forwarding decision. To refer the routing table, it will go to the routing table and it will ask same question: do I have the information to reach to the destination or not? Right? So this is the function of the router. Router is also an intelligent device. As soon as router receives a packet on its interface, it will open a layer 3 header and refer the routing table and take the forwarding decision. Right? Now I am saying refer the routing table. If you remember in the switch was referring the MAC address table, and MAC address table was getting created with the help of the through method. The one is static, another is dynamic, right? So router is an intelligent device. As soon as router receives a packet at the layer 3 on its interface, it will open a layer 3 header and refer the routing table. Refer the layer 3 table. And layer 3 table is the routing table. In the switch, if you remember, there are two ways to have the MAC address into the MAC address table. One is static way, another is dynamic. Static where admin needs to put the MAC address entry. Dynamic means where switch will automatically learn the MAC address when a frame travels through the switch. In router also, we have the method. So there are three methods. So router is the intelligent device. As soon as router receives a packet on its interface, it will open a layer 3 header and refer the routing table and take the forwarding decision. So here routing table. In the switch, in case of switch MAC table, here is the routing table and routing table is the layer 3 table. Here also we have the same static, dynamic, one more is directly connected. So there are three ways. Here there are three ways to populate or populate routing entry in routing table. So first is static, second is dynamic, third is directly connected. So static means same thing, admin, where admin will log into the router and put the static entry. So in the static entry, we have the static protocol. I will remove this. In the static, we have a routing protocol that is called static routing protocol. In the dynamic, we have the dynamic routing protocol. Means what does it means? If you configure any down in a dynamic routing protocol, so router will automatically learn the routing table. It will automatically learn the routing table to reach to the destination. So in that section, we have the multiple protocol. Like you have RIP, IGRP, EIGRP, OSPF, ISIS, BGP. So these are the protocols that router uses to learn the routing table dynamically. Right? So third approach is directly connected, means when we have the router, third way I am saying directly connected means if I have the router here, let's suppose I have a router here. On this router, if I am assigning any IP address 192.168.10.1, 192.168.20.1. So directly connected interface will automatically come into the router table. No need to do anything. Just assign the IP address on the interface, no shut the interface, it will automatically come into the routing table. You don't have to do anything. So there are three ways that router can populate or router can have the routing table. The first is static, where admin log into the switch and he will put the static entry. Dynamic approach means you have to enable this routing protocol, EIGRP, OSPF, ISS, and BGP. If we enable this routing protocol, router will automatically learn all the routing table. Third approach is directly connected. Directly connected means when we configure the IP address on the router, automatically it will come into the routing table. So these are the three ways that routing table can be populated into the routing table, right? And if you remember, if I start with the hub is the single collision and single broadcast domain device, right? This is hub, switch, router. So hub is the single collision domain device. Single collision and single broadcast, which is the multiple collision and single broadcast. router is the multiple broadcast, multiple collision and multiple broadcast. So if I write about the router, so router is the multiple collision and multiple domain device. It means every port of the router is the member of separate collision domain and separate broadcast domain. So every port of router is member of separate collision and separate broadcast. Every port of the router is the member of separate collision and separate broadcast. So router is multiple collision and multiple broadcast domain device. Here, so hub, single broadcast domain, single collision domain. Switch, multiple collision domain, single broadcast. Hub, router, multiple collision domain and multiple broadcast domain. Right? Done? And every upper layer device. If I start with the router at the layer 3, because router is referring a routing table. Router, layer 3, switch, layer 2, hub, layer 1. So every upper layer device, if I talk about the router, so router does the lower layer function. That means if I am the router will perform the layer 2 function and layer 1 function as well. If I talk about the switch will perform the layer 3, layer 3 also, switch, layer 2 and layer 1, right? So router means layer 3. So router will perform the layer 3 function, also perform the lower layer device function, means layer 2 and layer 3. But okay, switch cannot perform the layer 3 function, but switch can perform the layer 1 function and its own function, right? If I talk about the switches within the subnet, means all the PCs connected with the switch must be part of the same subnet. So switches within the subnet, router routes between the subnet, means two networks. If I have the switch here, router, I am saying switches within the subnet, router routes between the subnet. Between the subnet means, it means router is on this router interface. If I have this one subnet at the another interface, I will not have the same subnet. I cannot have the same subnet. That is what means between the subnet. Between the subnet means two different subnets. Right? What is the subnet will come in later. But I am saying switches within the subnet means in the same subnet, in between subnet means different subnet. It means The IP address or subnet which I have used here on the router, if I am using a subnet here 192.168.10.0/24, I cannot use same subnet on this interface. Because if I use the same subnet on another interface, it would be within the subnet. But router routes between the subnet means here we need to use the different subnet like 192.168.20.0/24. This is the design rule from networking point of view. Router cannot have the same subnet on interface, right? So no two ports of router, no two ports of router can have same subnet. Second is directly connected. Connected interface must be in same. No two ports of router cannot have same subnet. So that is the first point. Second is directly connected interface must be in same subnet. It means if I have a one router here, another router here, if I am connecting these two router R1 and R2, they must be in same subnet. If I am using a IP address here 192.168.10.0/24 on this interface, and then on in this interface I also need to use from the same subnet, right? So the previous was every upper layer device perform the lower layer device function. Router can perform the layer 2 layer 3 function. So layer 2 and layer 1 function. And switches within the subnet and router routes between the subnet. So it means no two ports of router can be in same subnet because in between the subnet means different subnet, right? Is it clear? If that is clear, then let's come for the packet flow. So in this packet flow, we'll cover the switch and we'll cover the routing. And also we'll cover the PC, the behavior of the PC. How does PC identify that I need to go into the same subnet or different subnet? And how does switch open a packet? And how does router open a packet? Right? So B here. This is my router. It's very important topic, right? If you have any doubt at any moment, please stop me because it will take almost 1 hour to explain everything, right? So I cannot come back. If you have any doubt, immediately stop me because we need to understand from the switch PC point of view, then routing from the switching point of view, then routing point of view. That is from one side. At the other side also we need to understand the forward flow, then the backward flow, right? It will take a lot of time. So they stop me at any point. So this is one router. This is another router. Let's consider this is here in high-tech city, and this router is somewhere in other location of the Hyderabad. Now this router is connected with the switch. Again, here also I have a switch. This is R1 router, this is R2 router, this is switch 1 and switch 2. and I have a PC here, and one more PC. This is PC with the host name AA, and MAC address is also A. BB, and here CC and DD. This router is connected with each other. So if this router is there, then we'll also have the MAC address. So let's suppose the R1 is having MAC address RR, and this R2 is having MAC address. Okay, RR cannot be. Okay, can RR be MAC address? Huh? RR can it be MAC address? RR cannot be MAC address because it will go till max to max F. So let's suppose here the MAC address is 01 and 02. This can be right now. So from the PC point of view, the PC will have the two tables. Which are two table? Layer 2 table and layer 3 table. Right? So the PC will have the layer 2 table. Okay, don't write that down anything, just understand first. Layer 2 table means MAC table. And this PC is having one NIC card with the IP address 10.10.10.1. This is having MAC address IP address 10.10.10.2. And here IP address is 10.10.10.10. Right? On this interface, I have the IP address 192.168.10.1. On this interface, I have the IP address 192.168.10.2. Here, I have the IP address 10.10.20.1, 10.10.20.2, and on this interface, I have the IP address 10.10.20.10. And MAC address is also there. AA, BB, CC, DD, and R1 having 01 and R2 having 02. Right? So every PC will have the two tables. One is R table, another is L3 table. Right? So R table means layer 2 table. In that, it will have the information that 10.10.10.1 is having MAC address AA. Layer 3 table, one 192.168.10.1 and 10.2. Clear? So now, so this PC L2 table, in that they will have the information 10.10.10.1 is having AA, and L3 10.10.10.1. That is the address of the NIC card. Correct? In the same way, other PC also have BB, CC, DD. I will not write. I will write only one here, the D, because we need that. So D L2 table is 10.10.10.1. 20.2 having MAC address DD. This is the ARP entry. ARP entry is the binding of MAC address plus associated IP address. Layer 3 10.10.20.2 NIC card. Network interface card where we have assigned this IP address. Right? Now this entire flow will divide into two parts. First of all, don't focus on the right side, just focus on the left side first. Right? Now the requirement is okay. Another thing, right? Here the interface is 0/1, 0/2, 0/3, 0/0, 0/1, 0/0, 0/1. So from the switch point of view, from the switch 1 point of view, it will have the which table? Layer 2 table. Layer 2 table means अरे switch में MAC table होता है. Here it will have the information that AA is connected on 0/1, BB 0/2, and what is the MAC address? 01 is on 01 and is on 0/3. Correct? That interface, right? Here. This is the MAC address, right? So it's connected on 0/3. Correct? Now, first point. I want to have a communication from AA to BB. I need to have a communication. I want that AA can communicate with BB. That means I want to know the network layer status, IP upper layer status of the BB. If I want to know the network layer status, IP upper layer status, then I need to send something, then only I will get the reply. If I want to send something, then PC will create a frame, right? If the PC sends a frame, then only it will come to know that whether that guy is active or not. So what I am going to do, from the PC1, PCAA, I will open a command prompt and I will put the command ping 10.10.10.2. This is what the IP address of B. When I put the command ping 10.10.10.2, PC will create a frame. In the frame, the first field, what is the first field? Data. The next is IP address. IP address, source IP and destination IP. Source IP means its own IP address. So it will go where? IP address means layer 3 routing table. It will go to the routing table and it will ask what is my IP address. Routing table will reply that I have a single link card which has the IP address 10.10.10.1. So it will simply put it here 10.10.10.1. Then what is the next field? Next field is destination IP. This is source IP. Then destination IP. Before putting the destination IP address, PC performs two things. First, it will go to the routing table and it will ask, can we have the reachability with 10.10.10.2? Now the PC routing table reply that there are two cases once again. If PC knows the how to reach, then it will reply that okay, we can reach it. If not, then it will reply that I cannot reach. So in this case, both IP address are in same subnet. 10.1, 10.2, both are in same subnet. That means the PC knows how to reach to the destination. But how does PC identify that it's in the same subnet or different subnet? There is a process called AND operation. You guys know this OR operation, AND operation, XOR operation, right? So AND operation, in that it will take the two things. The first is source IP and source subnet. Destination IP and destination subnet. Over the source IP, source subnet, destination IP, destination subnet, it will run the AND operation. If the result comes same, that means it is in the same subnet. If result is different, then PC will understand it is into the different subnet. So in our case, the source IP, source subnet, destination IP and destination subnet both are in same. In that case, PC will get the same similar kind of output with the help of the AND command. Then PC will come to know that the destination IP is also in same subnet. If the destination IP is in same subnet, then PC will put the destination IP address. So before performing this thing, PC will go to the routing table. Why routing table? Because IP is the layer 3 table. And in the routing table of the PC, it will ask, do we have the information? Before putting to the destination IP address, it will say, okay, I have a NIC card which is in the same subnet, right? And how does PC identify that is in the same subnet or a different subnet with the help of the AND operation? It will perform the AND operation with the help of the two things, source IP and source subnet. Both actually source IP and source subnet both are part of the same. The destination IP and destination subnet. Over that, it will run the AND operation. If result is same, then in the same subnet, this result is different. That means in different subnet. So in our case, it will run the operation. It will come to know that it is in the same subnet. Then it will put the destination IP address. What is the destination IP address is here? 10.10.10.2. 10.10.2. Then what is the next field? MAC address. MAC address is source MAC address. What is the source MAC address? MAC address is layer 2 information. For layer 2 information, PC will go to the layer 2 table, ARC table. And in that, it will ask what is the MAC address for 10.10.10.1. And ARC table will reply that I have the binding of binding of 10.0.0.1 with the A. So it will simply put the information A. The next destination MAC address. This is source MAC address. Destination MAC address. Now the destination MAC address means layer 2 information. It will go to the layer 2 table and will ask what is the MAC address for destination IP 10.10.10.2. It will go to the ARC table here. But in the ARC table, do I have the information for 10.10.2? No. In that case, what is going to happen? PC will drop the packet, or what is going to happen? What? Drop the packet. At the layer 2, if destination MAC address is unknown, PC sends R broadcast. It will send a R broadcast on which MAC address? FF, right? So now this time PC will not have the destination MAC address. So instead of this, what the PC is going to do? PC will park this packet aside. PC will park this packet aside and it will create a R broadcast. R broadcast is to get the MAC address. Send the destination IP to get the MAC address. Again, PC will create a frame, and this time the frame is the R broadcast. In the R broadcast, what information I need? I need the destination. I need the MAC address for 10.10.0.2. So this is data. In the data, it will put down the request that I need the MAC address. The next field is source IP. Source IP is what? 10.1, destination IP 10.2. I can write like that. Then MAC address AA. Destination MAC address is FF. Because PC doesn't know the MAC address for 10.2. Now I have the complete frame. If you remember, for Ethernet communication, the final communication over the Ethernet happens with the help of the MAC address. So now I have the MAC address, source MAC and destination MAC. Destination MAC address is FF. But the PC, any network device, any communicating device, accept the three kind of packets. The first is unicast, broadcast, and multicast. Now this packet will go to the wire. It will go to the wire and it will reach to switch. And switch creates the multiple copy of the frame in which case? Which all the cases when switch creates the multiple copy of frame? There are two cases. But they are not going through that. You guys have to understand. Because no need to discuss this. So switch create the multiple copy in two cases. First is when switch receive the broadcast frame. Second is when switch doesn't know the destination MAC address. So here, what is the frame? Broadcast frame. Broadcast frame, right? The switch A is sending a broadcast frame. And when a switch receives the broadcast frame on interface, it will create a multiple copy and forward to all of them. Now, what is going to happen? It will send a one copy here and another copy here. Let's suppose from the R2 point, R1 point of view. When a R1 receives the layer 3, okay, at the layer 3, what is that? That is called, we call as a packet. When R1 receives a packet, it will open a layer 2 header. Why it is opening a layer 2 header? If router is a layer 3 device, then it would open a layer 3. And remember, just now we have discussed that every upper layer device can perform the lower layer function. So router will open a layer 2 header. In the layer 2 header, it will see that destination MAC address is FF. That means it's a broadcast MAC address. I have to accept because every communicating device accept three kind of MAC: unicast, multicast, and broadcast. This is the broadcast. I need to accept. Now, rest of the information will go to the IP upper layer protocol stack, means IP address. IP address is sitting at the top of the layer 2, and it will open a layer 2 header, layer 3 header. In the layer 3 header, it will see that source IP address is 10.10.10.1, destination IP address is 10.10.10.2. Both are in same subnet. But I am the router, my job is to route in between the subnet, not within the subnet. Both are in same subnet, simply router will say, no, don't come to me. You are guys are in same subnet, talk to each other. No need to come on the router. So router will simply discard the packet. Why? Because both are in same subnet. If both are in same subnet, the router will not come into picture because router routes between the subnet. Now that router will discard the frame. What happened to this guy? Packet will come here. As soon as PC receives the frame, it will open a layer 2 header. In the layer 2 header, it will see the destination MAC address is FF. That means it's a broadcast. I need to receive that. It will receive, and rest of the information it will forward to IP upper layer protocol stack. IP upper layer protocol, who is sitting there? IP. IP will open a layer 3 information. In the layer 3 information, it will see the destination IP. What is the destination IP? 10.2. I am also 10.2. That means this packet is destined to me. Right? That this PCB will also make an entry into the layer 2 table. In the layer 2 table, it will make an entry that 10.10.10.1 is having MAC address AA, and it's already 10.10.10.2 BB. Because BBB already will be there, right? When you create, when you assign the IP address, when you have the NIC card, automatically the MAC address center will come. But the other PC will come via this process. Now, rest of the information, data will go to the upper layer, application layer. In the application layer, a person is sitting called application. That person will open up information, and if we see that that guy is requesting to have the MAC address of 10.0.10.10.10.2. PC will get the MAC address from the ARC table. Now, this time BB will reply. In the reply, the first is data. In the data, it will put down the MAC address. Which MAC address? BB. Then source IP. What is the source IP this time? 10. Now BB is replying now. So BB replying means it will become source IP. Destination IP address is what? 10.1. Source MAC address BB. Destination MAC address. Destination MAC address, it will go to the layer 2 table and it will ask what is the MAC address for 10.1. So we already have the entry. So it will simply put the information here. When we have the complete information, source IP with the source IP, destination IP, MAC address, source MAC, destination MAC, frame will go over the wire. Right? Now the frame will go over the wire, and this time, what do you think? What will happen? Switch will open a layer 2 information, and this time is the unicast, not the multicast, not the broadcast. Unicast. So switch will receive the frame, and switch is the single device who asks from where you came. And the frame will reply that I came from source MAC. What is my source MAC? BB. Destination MAC is AA. And it will go to the layer 2 table. It will refer the MAC address table. In the MAC address table, AA is catered on which interface? 0/1. So simply it will bridge the information here. It would not go to the router. Now this frame will come to the PCAA, and PCAA will open a layer 2 header. In the layer 2 header, if you see the destination MAC address is AA, that means it's my MAC address. This frame is destined to me. It will keep the information, and rest of the information it will forward to IP upper layer protocol stack. IP upper layer protocol stack open a IP address. In the IP address, it will see the destination IP is 10.1. I am also 10.1. That means this packet is destined to me. Then rest of the information will go to the application layer. Application layer will see in the content, in the data, I have the MAC address DD. And sometimes ago, I requested to get the MAC address because I forwarded the ARC broadcast. Now I have the MAC address. Now the PC will note down the MAC address 10.10.10.2 having BB. Correct? Now the original request. This guy gone, and original request will come into the picture. In the original request, data, I want to know the network layer status, IP upper layer status. The next field is source IP 10.1, destination IP 10.2, source MAC AA, and destination MAC. For the destination MAC, again PC will go to the layer 2 table. In the layer 2 table, if you see, I have the information for 10.10.10.2 that has the MAC address BB. Now it will put it here. Now this frame is complete. Now this frame will go to the switch. As soon as switch receives a frame, it will open a layer 2 header. In the layer 2 header, it will see the destination MAC is BB and source MAC is A, and it will go to the MAC table. It will refer the MAC table. In the MAC table, you will see BB is connected on which interface? 0/2. It will simply bridge the signal from here to here, and you will have the public. That is the first point. Any doubt here? In the second point, let's suppose this time I want to have a communication from A to DD. If I want to know the network layer status, IP upper layer status of DD, then I need to send a ping. So instead of that IP address, I need to use which IP address? Ping 10.10.20.2. Let's remove it. Before coming to that point, there are two things. The first, router. In the routing table, directly connected interface will come automatically, right? So if I talk about the R1 point of view, this is my R1 router, and this is R1 routing table. In the routing table, I will have the information that 10.10.10.1 is connected with the 0/0, and 192.168.10.1 connected with the 0/1. Directly connected. I don't have the space actually, that is what I'm not writing. But in the routing table, you will see something like this. 10.10.10.1 directly connected 0/0. It is like that. But I don't have the space. Let's remove it. 0/0. Similarly, R2 will also maintain the routing table. So this is R1 and here is R2. R2 routing table. In that 192.168.10.2 0/0 10.10.20.10 on 0/1. Right? Now, every upper layer device also perform the lower level function. That means which will also contain the MAC table in form of the R matrix. So here it's not required. Let's remove it, right? So router L2 table or R table. In that it will have the information that 10.10.10.10 is having 0/1 and 192.168.10.1, let's suppose 0/3. So this is the MAC address here is interface 0/3 and this is 0/2 and let's suppose this is 0/4. Correct? MAC address I'm not writing the entire thing, just 01, 02, 03, 04. So in the same way, R2 will also have the L2 table. In that, it will have the information that 10.10.20.10 is having MAC address 04 and 10.192.168.10.2 is having 02. So from the router point of view, we'll also have the two table, router table and L2 table. From the switch point of view, we'll have the L2 table. But from PC point of view, again we'll have the two table, L2 table and L2 table. Correct? Now, let's come to the actual requirement. Now I want to know this guy D, whose IP address is 10.10.10.20.2, whether that guy is active or not. I want to know. If I want to know, then I need to send something. Then only I will come to know whether he is active or not. So what I will do, I will open my command prompt. Over the window, I will open my command prompt. I will put the IP address P 10.10.20.2. Now, to know the DD network layer status or IP layer status, PC will create a frame. In the frame, first field is data, right? So this is data. The next field. Source IP. Source IP is what? 10.1. So source IP 10.1, destination IP. Now what is going to happen here? Interesting. So destination IP address means what? Layer 3 information. PC will go to the routing table and it will ask two questions. First is, do I have the information to reach 10.10.20.20.2? Sorry, mobile. Destination IP is what? 10.10.20.2. The PC will go where IP means layer 3 table, layer 3 table. This is layer 3 table. Either here, small one. In the layer 3 table, if you see, do I have the information about 10.10.20.1? Not available. In that case, what is going to happen? PC will drop the packet. Layer 3 packet, remember, layer 3 packet. At the layer 2, if you don't have the information, it will send a R broadcast. But at the layer 3, if destination IP is not reachable, simply drops. I will not entertain. Why? Why? So remember, layer 2, it will send the R broadcast to get the MAC address. At the layer 3, if PC or router doesn't know, if the PC and router don't know the destination, how to reach to the destination, they will simply drop the packet. Not going to get it. You just come with your solution, then I will route the packet. But if that is the case, then my PC will not communicate. Anyhow, today no one joined. So, right? If that is the case, then you will not able to communicate with any other person. Because I will not have this PC cannot contain the entire routing table. In my PC, I cannot contain the entire routing table. In that case, PC will go again to the routing table. Okay, that's fine. You are saying that you don't have the information. But do you have any gateway that can help me to reroute my traffic? So the PC will also have the gateway. Gateway is what? For this entire network. What is the gateway? Gateway is the router IP address 10.10.10.1. Sorry, 10.10.10.10. So that is the gateway. If all the PCs inside the LAN, if they want to go to the outside, because I am going to the different subnet, in that case, I need to forward the packet to my gateway. So in this room, right, if anyone wants to go, he cannot go via window. He has to go via this door. For you all, and even for me also, this is a single gateway. Have you ever seen? I go from here. Every time I go from here, right? So that is the gateway. So it will also have the information that is called default gateway, DZ. I'm writing DZ, default gateway 10.10.10.10. In the routing table, it will also have the information that DZ is having 10.10.10. How? Let me show. What is the command to check the routing table? In the PC. If you give this command, you will see the gateway. So this gateway, this is the guy here. You need to play. Gateway is router. Now the PC will go to again routing table and it will ask, okay, that's fine. You are saying that you don't have the information about 10.10.20.2, but do you have any gateway configured? PC will reply, okay, I have a gateway with the IP address 10.10.10.20.10.10.10.10.10. That is my gateway. If PC is replying that I have the gateway, then only PC will put the destination IP address. How does PC know that the destination IP is different subnet? Now again it will perform the AND operation. What is the IP address here? Destination IP address. Now the PC has the default gateway. If the default gateway is available, then it will put the destination IP. Destination IP address is 20.2. What happened? PC saying that's fine. I don't have the destination address, but I have the gateway. That gateway help you to route the traffic from one subnet to another subnet. In that case, PC will put the destination IP. What is the next field? Source MAC. Source MAC address means its own MAC address. Where it will go? Layer 2 table. In the layer 2 table, we see the MAC address is AA. Right? Then destination MAC. What is the destination MAC? In case when you have the communication from one subnet to another subnet, destination MAC address is always router MAC. Always gateway MAC address. And who is the gateway in this case? Router R1. What is the MAC address on the interface that is connected to a switch? 01. 01, right? This is the MAC address now. So it will put the 01 MAC address. Now I have the complete information. This packet will go to where? On the wire. And it will come to the switch. As soon as switch receives a frame, it will open a layer 2 header. In the layer 2 header, it will see the destination MAC address is, source MAC address is AA, destination MAC address is 01. When switch opens a layer 2 header, it will refer the MAC address table. Now it will go to the MAC address. In the MAC address table, this guy 01 is created on which interface? 0/3. It will simply bridge the signals from 0/0 interface to 0/3 interface. So 0/1 interface, it will simply bridge the signal from 0/1 interface to 0/3 interface. Right? Now it will come to the switch 3 interface. which 0/3 interface, and from there it will reach to the router. Right? Now router will have this information. This is the packet. This is the packet which is coming at the layer 3 router. Now router will open a layer 2 header, because every upper layer device perform the lower layer device function. Layer 2 header, it will open a layer 2 header and will see the destination MAC address. Destination MAC address is 0, 1. I am also 0, 1. That means this packet is destined to me. It will open that information and it will also note down that AA is having 10.10.10.1, because the AA is the MAC address of 10.10.10.1. The router will also note down this information and it will open a layer 3 header. In the layer 3 header, it will see the destination IP. Destination is IP what? 20.2. The router will go to where? Routing table. In the routing table, it will ask routing table, tell me, can you help me to read? Can you help me to read 10.10.20.2? Router will say no. Do we have any information into the routing table about the subnet? I have the 10.10.10.10. I have 192.168.10.1. But I don't have the information for 10.10.20.2. In that case, router will simply drop the packet. At the layer 3, PC and router, if they don't have the information, they will simply drop the packet. But that is not case. Every time router is dropping the packet, then we not have a communication with the provider. Right? Because that guy is sitting there, right? He will not have the communication with who is the packet now. Modi is silent. No one is there. Right? So we will not have the communication. Then we need the solution. Right? The solution is what? Routing table. A routing table can be populated with the 3 methods. The one is directly connected. Directly connected interface already there. Another is static and dynamic. So we need to perform the dynamic routing protocol or static routing protocol. So let's forget about the dynamic. Let's go to the static. So here I will make an entry that if you want to go 10.10.20.2 forward packet via 10 dot via 192.168.10.2. If I forward my packet here, it will come to R2 and 10.10.20.2 is directly connected with the R2 another interface. 20.10, right? 20.10. So it is directly connected. Consider that is the same subnet. So it is in the same subnet. So now router 2 knows how to reach to 10.20.2, right? So on the routing table, in the routing table, I will put a static entry. S means static entry, that if you want to reach 10.10.20.0/24 subnet, let's consider subnet. If you want to reach 10.10.20.0/24 subnet, set a packet to 192.168.10.2. And 10.2 is configured on which router? R2. And R2 At the other lane, 10.10.20.0/24 is directly connected. So the router 2 will help me to route the packet, right? Now this guy R1 is having entry into the routing table. Now again it will come to the routing table and ask, can you help me to route my packets to 10.10.20.2? Router will reply, this time router will reply, okay. If you want to go, I need to send your information on this interface. And this interface is directly connected with the R1. Right? So at the layer 3, if the router doesn't know how to reach to the destination, it will simply drop the packet. If router knows how to reach to the destination, then router will modify the packet. Router will modify the packet. In that, it will change the source, MAC, and destination. For Ethernet communication, for end-to-end Ethernet communication, source IP and destination IP address will never change. Only the source MAC address and destination MAC address will change. That is also out by router to router. Now I am saying router knows how to reach to the destination. If router knows how to reach to the destination, the router will modify the packet. And modification only in the source MAC and destination MAC. So this is the actual frame. Right? Here I am saying if router knows to the destination, then it will modify the frame. Modification only in source IP and destination IP. Right? Source IP 10.1, destination IP 20.2, and source MAC, this time router will put its own MAC address. What is the MAC address of this interface? 03, correct? Again, if you see, source IP and destination IP both are in different subnet, right? If source IP and destination IP address both are in different subnet, then the destination MAC address would be gateway MAC. So from this point of view, from here, from the entire network point of view, this is the gateway. And this gateway R2 interface is having MAC address 02. It will put the MAC address 02. And if you see, earlier I had the MAC address AA and 01, but now the MAC address is 03 and 02. It means router is modifying the frame. Router is taking participation into the routing to take the decision. If any device taking participation into decision making, that device will modify the frame. That is what router is doing. Router is modifying the frame. In that also only the source MAC and destination MAC. For end-to-end communication in Ethernet technology, the source IP and destination IP address will not get changed. Never. Now this is changing. Now this is frame or packet. Layer 3 packet. This packet will come to router 2. This will come to router 2. And router 2 will open a layer 2 header. In the layer 2 header, it will see the destination MAC address. What is the destination MAC address? 02. And what is the interface MAC address? That is also 02. That means this packet is destined to. Then it will open a layer 3 header. In the layer 3 header, it will see the IP address. What is the IP address? Destination IP address 10.10.20.2. Source IP address is 10.10.10.2. 10.1. Both are in different subnet. As soon as router open a layer 3 information layer 3 header, it will refer the routing table. In the routing table, it will ask, can you help me to reach to the destination? Now router will reply that the destination IP address is destination IP address is 10.10.20.2. This destination IP address 10.10.20.2 that is directly connected with my interface 0/2/1. Let's suppose /1. So that is directly connected because .1, .2, .3, .4 till .54. It will come in the same subnet. That is directly connected. In that case, router has the information to reach to the destination. If router has the information to reach to the destination, router will modify the. In that also only the source MAC and destination MAC. Right now, this time the source MAC will become the 04, and destination MAC is what? MAC address means layer 2 table. Router will go to the layer 2 table and it will ask, do we have information of MAC for 10.10.20.2 or not? Here is the MAC table. In the layer 2 table, MAC table, do we have any information for this guy 10.10.20.2? No. In that case, at the layer 2, destination MAC is not known. Then what is going to happen? R broadcast. This layer 3 packet will be parked aside and router will generate a R broadcast to know the MAC address of 10.10.20.2. Now, here data R broadcast source IP. What is the source IP? 10.10.20.10. Destination IP is what? 20.2. Source MAC 0.4. Destination MAC. Destination MAC is R broadcast. R broadcast destination MAC is FF. It will put a FF here, and this will come to the wire. It will come to the switch as well. Now, switch is receiving a broadcast frame. If switch is receiving a broadcast frame, then it will create a multiple copy of the frame and will forward to all other interfaces. It will come to the CC and DD. So CC will drop the packet because IP address is not matched. IP address is 10.2, but the C is having 20.1. D is having 20.2 and C is having 20.1. But in the destination, we have the IP address 20.2. It's not matching. It will drop the packet. Now, and when it dropping the packet, it will also note down that MAC address information into the MAC table, R table. It will come to D, and D will open a layer 2 header. You see that the destination MAC address is FF broadcast MAC address. It will receive the packet and it will open a layer 2 information. In the layer 2 information, it will see that my IP address is 20.2. I am also 20.2. That means this is destined to me. In that case, it will receive and rest of the information forward to IP upper layer protocol stack. IP upper layer protocol stack will open a layer 3 layer application layer. In the application layer, it will see that the guy is requested for the MAC address. It will put the MAC address and it will reply back to the router. Now, router will have the MAC address entry that 10.10.20.2 is connected with the DD. It has the MAC address. Again, router will create a in the packet data, source IP, destination IP, both will not get changed. It is same. Now, router knows how to reach to the destination. The router will modify the frame. So, router will modify the packet. In that, source MAC address. Source MAC address would be 04. This guy. Destination MAC address would be DD. For destination MAC address, it will go to the layer 2 table. In the layer 2 table, it will ask what is the MAC address for 10.10.20.2. It will reply that DD. Now the frame is completed. It will come to the wire and it will also come to the switch. When it comes to the switch will open a layer 2 header. In the layer 2 header, it will open a layer 2 header and it will refer the MAC address table. So switch will also contain the MAC table. In that it will have the information that CC stated on 0/1 and DD connected on the 0/2. Let's suppose 0/3. 0/3, sorry, 04 is having 0/3. If we see that DD is connected on the 0/2, it will simply bridge the signal to bridge the information to DD, not to the other place. This is the one-way component. Clear? Now the packet has reached to DD. Now the DD will also reply, right? If the D is not replying, then how would you come to know that DD is active or not? Right? Let's come. So now DD is going to reply. Now D will reply. When a D replies, it will put the data, then source IP. Source IP is what? 20.2. Destination IP is 10.1. Source MAC. Source MAC address means its own MAC address, DD. Destination MAC address. A. But the both are in different subnets. And in that case, destination MAC is router MAC address. Source MAC address, source IP is 20.2, destination IP is 10.2, 10.1. Both are in different subnets. If we have the communication in different subnets, then router will put the, a PC will put the gateway MAC address, not the destination MAC address. So gateway MAC address, right? MAC address is layer 2 table. It will go to the layer 2 table and it will ask what is the gateway. So gateway is DG here, gateway. The IP address is here is 10.10.20.10. It has the MAC address 04. So it will put the 04. Here is the 04, right? So that is the gateway. That is the gateway for that PC. So it will put the MAC address 04. Now this frame is completed, it will come to the wire and it will reach to the switch. Switch will open a layer 2 header. In the layer 2 header, it will see that the destination MAC address is 04 and that destination MAC 04 is being learned on 0/3. It will simply reach the signal from here to this way. And it will come to the router. Router is the LC device. As soon as router receives a frame, receives a packet on its interface, it will open a layer 3 header. And it will also perform the layer 2 header, layer 2 function, because every upper layer device performs the lower layer device function. So it will open a layer 2 header. In the layer 2 header, you will see that destination MAC address is 04. I am also 04. It will load down the information and it will pass the rest of the information to IP upper layer. IP upper layer information will open a layer 3 header. In the layer 3 header, it will see the source IP is 10.10.20.2 and destination IP address is 10.10.10.1. It will go to the routing table and will ask routing table, can you help me to route this packet? It will ask routing table that can you help me to route this packet? Routing table will see, okay, let me look up my routing table. In that, it will start looking up the routing table. 192 I have, 10.10.20.0/24 I have, but I don't have 10.10.10.0/24 information. In that case, router will simply drop the packet. But I don't want this to be happened. In that case, what I need to do? I need to perform the routing. A routing can be done via two ways, static and dynamic. In that case, let's use the static protocol. So I will log into the router and I will put an entry, that static entry. Yes, static 110.10.10.0/24 via 192.168.10.1. For this entire network, the gateway is this guy. If I send a packet to 0.3, means router 1. So router 1 will help me to route my packet because 10.10.10.0/24 is directly connected on this interface. Right? Now the router has the information to reach to the destination network. If router has the information, if router doesn't have the information, router will drop the packet. If router has the information to reach to the destination network, the router will modify the packet. In the modification for Ethernet communication, end-to-end Ethernet communication, the source IP and destination IP will not change. Only the MAC address will change. In the MAC address, router will put its own MAC address. So here data. Source IP is what? 20.2, destination 10.1. Source MAC will be a router MAC address 002 and destination MAC address. Both are in different subnet. If both are in different subnet, then the MAC address would be gateway MAC address. And this is the gateway for this entire network. So 03. And this information will come to the router 1. As soon as router receives a packet on interface, it will open a layer 3 header. In the layer 3 header, it will see the destination IP address and source IP address. Right? It will also open the layer 2 header. In that, it will see the 0.3. This is the 03. And I am also 03. That means this is destined for me and let me forward other packet to other information to IP upper layer protocol stack. IP upper layer protocol stack will open a layer 3 header. In the layer 3 header, it will see the destination IP is 10.1. I am the router. I need to perform the routing. Then it will go to the routing table. In the routing table, it will ask, can you help me to route my packet to 10.10.10.0/24 subnet or 10.10.10.1. Router will say, wait, let me look up my router. Router will look up the routing table and it will see that this guy 10.10.10.0/24 is connected on 0/0 interface. This is this interface. It will simply forward that packet. If router knows the destination, how to reach to the destination, the router will modify the packet. In the modification, source IP, destination IP will not change. The source IP and destination IP address will get, source MAC and destination MAC will get changed. Now, router will modify the frame. Here, it will put the, this is my, this is source IP, source MAC. In the source MAC, router will put the 01 because this 0/0 interface is having MAC address 01. And this guy, destination MAC address. In the destination MAC address, it will go to the layer 2 table. In the layer 2 table, it will ask what is the MAC address for 10.10.10.1. And if you see here, here, it has the information that AA is connected on what is the MAC address for 10.10.10.1. It will simply put the AA. And this packet, this packet will come to the switch. As soon as switch receives a frame on its interface, it will open a layer 2. In the layer 2 header, it will refer the MAC address table. What is the destination MAC address here? A. And it will see that AA is connected on 0/1 interface and it will simply reach the signal from here to here. And it will come to the PC A. PC will open a layer 2. In that, it will see the destination MAC address is A. That means this is destined to me. I am also A and the destination MAC address is also A. Then it will open a layer 3 header. In the layer 3 header, it will see the source IP and destination IP. Destination IP is what? 10.1. I am also 10.1. That means it's destined to me. Again, it will open a data. In the data, we have done the ping. Ping means type 8 code 0. Now, this time he is getting a type 0 and code 0. That means echo reply. Earlier it was sending echo request with the type 0 and code 0. Now he is getting the type 0 code 0. That means echo reply. Now the PCAA will come to know that this guy DD is active and alive. He is responding back. If we don't get any reply, that means PC is not replying. So like same way, if you ping, let's suppose 8.8.8. So it will send the 4 packets, right? So in the back end, this all thing happen. From our point of view, just ping, get the response. But these all things happen into the back end.